All right, we've got 4 practice questions, and they kind of leap ahead a little bit, but they're fair. We just got to learn how to do them. So a plant is shut down. On the first one, a plant is shut down, and steam is escaping to atmosphere through a leak in the steam line. Main steam line contains, this is key phrase, dry saturated steam. That means we're at the G point. G, dry saturated steam, at 300 psia. So there's the pressure, and we know it exists as a dry steam, a dry vapor. What is the temperature of the steam as it reaches atmospheric? Well, if we were to apply the general energy equation to essentially, that's a throttling process. That is no different than this being a valve going to atmosphere, and here's our pipe with 300 psia in it. And it's just throttling the atmosphere, the pressure drop. If we were to apply the general energy equation to this, let's just do that. Potential energy plus kinetic energy plus enthalpy plus any heat that I add must equal potential energy plus kinetic energy plus enthalpy plus work. So let's apply that. This is the inlet. So this is inlet conditions. This is the outlet. The process occurs through that valve. So this is the outlet. So from inlet to outlet, is there a big change in height? The potential energy change? There is not. So we cross those out. When the valve's open and steam is going through it, is there a difference in velocity between the inlet and the outlet? There is not. So there's no change in kinetic energy. Is there anything that adds heat? Is there a boiler inside this valve? There is not. Is there anything that spins, that takes work, extracts work out of the steam, or is there a pump in there? Is this a device that works? Work means motion. It's a pump and a turbine. There is not. So what we see is the enthalpy in to this valve equals the enthalpy out. A throttling process is a constant enthalpy process. That's important because we're going to now go to our Mollier diagram to solve this problem. And I'm going to find the 300-pound pressure line, and I see it exists right here. And I know the 300-pound pressure line that's going like this. I started inside the pipe on the line because I'm a saturated vapor. And now I'm going to drop pressure to atmospheric pressure. If I drop pressure like this, I'm changing enthalpy. And we just realized a minute ago, a throttling process is a constant enthalpy process. So I have to drop pressure in this direction during a throttling process. So whatever the enthalpy is, and it looks like it's about 1,205 BTUs per pound mass, as I come across, straight across on a constant enthalpy, you'll see the temperature that I'm just above is about a little higher than 320 degrees. That's what's occurring. That's the downstream temperature of this throttling process. And at atmosphere, I know saturation temperature is 212, so the steam that's escaping is up here in this superheated region, and its temperature is just above 320 degrees. If you look at your available answers, I would pick Charlie. Just above 320 degrees is 322.